Good evening, sir. Yes, sir. A very good evening, everyone.
Good evening, ma'am.
Good evening, Deepa ma'am. So, shall I start? Yes.
Yes, ma'am.
Yes. So, I think as there is a gap of a day, yesterday we haven't seen anything. So, I will give you a 1 minute recap what we have seen in the on the day one. So, day one was the basics of Excel. I tried to explain you how you can use Excel for the data analysis. We have tried to understand the concept of descriptive statistics, and we have seen how we can apply descriptive statistics using Excel. Also, I have explained you that what is chi-square test. I told you this thing that chi-square test is the non-parametric test, right? And also, I tried to explain you how we can move or I have explained you the types. There is goodness of it, and also there is independence of attributes. And then we have seen that how we can apply goodness of it using the Excel, right? We have seen that how Excel can be used using various functions, how we can apply the statistical analysis through the Excel. This is what we have seen on a day one. Today is the day two. I'm going to explain the second part of chi-square test, which is the independence of attributes, and then we will see the t-test and its variety, right? So I think without delay, I am just sharing my screen and we'll see how we can understand. Did I explain you the concept? Any confirmation? Did I explain you the concept of independence of attributes?
Yeah, ma'am, please.
Sorry? Yes or no?
Ma'am, yes, ma'am. Yes, please explain little bit, ma'am.
Okay, fine. I'm sharing my screen. Give me a second. Okay, I think I shared my screen. I hope it's visible.
Yes, ma'am.
Fine. So I'll again start with the chi-square test. As I said, chi-square test is a non-parametric test. Purpose of chi-square test is to see the uniform distribution of the counts or the frequency. I explained you the types. First one was the goodness of it, where we are dealing with the one categorical variable. Categorical variable meaning is a variable can be measured on the nominal scale or it can be measured on the ordinal scale, right? This is the meaning of the ordinal scale variable. So this is what I have explained you for the chi-square goodness of it. That is a single categorical variable will be there. And when we talk about a categorical variable, that means there will be the categories, right? So say for example, suppose here I have given you the example of various types of games, outdoor games, and we are asking the preference of the people which games they are liking or something like that. And then we are counting how many of the people are liking cricket, football, etc. So that way we can say this thing that this is a kind of chi-square goodness of it, where we are having a single categorical variable preference to the outdoor games, and there we are having the four categories of the games. So we want to see the distribution of the frequencies throughout these four categories. So this was the goodness of fit test. Second test is the test of independence or test of association. This is the second kind of chi-square test. Here we will be having the two categorical variables, right? So two categorical variables, when we are talking about the two categorical variables, that means you need to deal with the contingency table. Contingency table meaning is it's nothing but it is a cross tabulation where you are keeping one variable in row and second in column, right? Is it clear? I hope it's clear. Not tough to understand.
Yes, ma'am.
Right.
Yes, ma'am.
Yeah. Now, if I talk about the example of contingency table, so say for example, I'm having a variable called suppose gender, and we know there are two categories in gender, although there can be other also, but we can taking only two, male and female. And suppose we want or we are asking the respondents about whether they prefer to have tea, suppose, right? So option can be yes and no. So suppose 52 males are saying yes, then 28 are saying no, right? Similarly here 65 are saying yes, and suppose 25 are saying no, females. Is it clear? I think not difficult to understand. Yes.
Yes, ma'am.
Yeah. So that way you can see it's 53 and 117. It's 127. No, 117. Correct, right? Fine. Friends, it is clear. So this arrangement of the categorical variables is known as contingency table. I hope you are understanding this.
Yes, ma'am.
Yeah. So in that case, if suppose, as I said, this is a two-way chi-square test or the test of association in the chi-square test category. So that way, what will be my hypothesis here? My hypothesis will be there is no significant association between gender and preference to tea. Is it okay? I think easy to understand, right?
Yeah,
Clear,
ma'am. Please
everyone?
proceed.
Sorry, do I need to repeat? It
Yeah.
is clear?
Clear, ma'am.
Clear, fine. So that way, if this is the way, if this is a case, that means this way we can make a formulator hypothesis. And whenever we are talking of the hypothesis, generally we need to check our hypothesis on a particular level of significance. Significance can be like 5%, 10%, 1%, etc. Usually in social sciences, we are dealing with the 5% level of significance, right? So this way you need to firstly you need to identify your variables, you need to tabulate your variables, and then after formulating your hypothesis, you can check it using the chi-square test, right? Now, to understand this chi-square test with an example, I'll come to the sheet which I already shared with all of you for the chi-square test. In this sheet, you need to come on the second worksheet named as Demo IOA, Independence of Attributes. So I'm coming on this. I hope everyone is with me and have opened the sheet. Yes, shall I start?
Yes, ma'am.
Yeah. Now, what you need to do in this sheet, firstly, I'm explaining you. Here, firstly, you can see what the variable or what are the variables given to us. We are having the two variables. First one, first one is whether the person is graduated or not, right? So that way you can find it is yes and no combination is given here, right? And then second, the wealthy or wealthier status, whether the person is wealthy or poor, this kind of, or middle, three status are given. Person is wealthy or middle wealthier level he is having, and the person is poor. These are the three different variables available in this particular sheet with us. Two variables. And the second variable, we are having the two labels, yes and no. And the first variable, we are having the three labels, wealthy, middle wealthy, and the poor label. Is it fine? Now, what we need to do to perform chi-square test, firstly, we need to prepare a contingency table. So that way you can see, I have already given you the format of contingency table. There one variable or the one variable that is graduation level, I'm keeping in a column with the two categories, yes and no. And the second variable, which is wealthy status, that is wealthy, middle and poor, I'm keeping in the rows. I think it is simple to understand, right? Shall I start performing the calculations now?
Yeah, ma'am.
Ma'am,
Sure,
do
fine.
we have to make this contingency table manually, or is there any formula for that?
This is you
Yes,
need to make for values. I'm telling you what you need to do now.
Okay, okay.
Now I'm using the filter, as already you can see, I have already applied the filter here, right? Now I'm coming, I want to make, or I want to count how many of the people who are wealthy, and graduation level is yes, right? So first filter I'm putting here in the wealthy, and in this I'm deselecting this and selecting only wealthy and clicking on OK. Done? Fine.
Ma'am, please repeat again this part.
Okay. I said you need to use the filter option. Filter option, I think everyone is knowing. Already in your worksheets, it is available. Drop down is available. You need to click on the drop down. Deselect, select all is, you can find select all checkbox is checked. So you need to click on that and select only the wealthy. Fine.
Yes, ma'am.
Yes, ma'am.
Now click on OK. After this, firstly, I want to check the combination of wealthy and yes. So again, I'm choosing the second drop down. I am select all. I am just checking, and then I'm selecting only the first category, which is yes, and clicking on the OK. That way, I need to select this cell, and you can see this particular column I selected, and you can find the count is coming as 6. So that means 6 people who are graduated, they are wealthy. Is it okay?
Yes, ma'am.
Similarly, again, I'm coming in a graduate. Rather than yes, this time I'm selecting no. So you can find the count is coming as 5, right? So I'm selecting all, clicking on OK, and filling this as 5. Is it done? Not tough, I think, right? Easy?
Yes, ma'am.
Shall I proceed to the next?
So actually, ma'am, we are finding out the different combinations.
Obviously, this is the contingency table. I think previously also I said this. As you can find, male, those who are taking T, 52, male, those who are not taking T, 28. So same way, here also you need to prepare this contingency table, right?
Yes, ma'am.
Now, in the wealthy, I'm selecting, instead of wealthy, I'm selecting the middle, right? Clicking on OK. And in the graduate, I'm selecting the yes, OK. So you can select the column and see total count is coming as 9. So middle and yes is 9. Then I'm counting middle and no. So middle and no is 7, right? So I'm coming. Okay. And I'm writing it is 9 and 7. Done. Now select the last category, that is poor. Click on OK. In graduate, selecting the yes, clicking on OK. You can count, it is 5. Poor, yes, combination is 5. And lastly, poor and no, which is 6. So it is 5 and 6. And then you need to make your data as it is, remove all the filters, and then write 5 and 6. Done. Now, I'm using the sum to get the total of the column, which is 20, dragging it to the next cell, and then Again, for the row total, I'm using the sum function and dragging. I hope it is clear.
Yes, clear,
Yes,
ma'am.
ma'am.
Shall I proceed to the next?
Yeah, sure,
Yes,
ma'am.
ma'am.
Yeah. After this, you need to copy this entire table. Do the Control C. And I'm pasting this on the blank place. And then I'm deleting all this, whatever the values written here. You need to delete this. Although there is no need of this total column, but I selected, so we keep it here, right? So this way, first table is the table which is for the observed frequency. Now you need to calculate expected frequency. Done? Shall I proceed?
Yes,
Yes,
ma'am.
ma'am.
Fine. For expected frequency, in case of chi-square independence of attributes, the formula is written here. You can find E is nothing but its expected frequency count, which says RT into CT, that is row total into column total divided by grand total, right? So say for example, for wealthy and yes categories, for this combination, I want to calculate the expected count. So for this 6, its respective row total, its respective column total, and then grand total is this 38. Getting me?
Yes, ma'am.
So now, so I'm coming here, putting a equal sign. For this, I'm selecting this is the row total, right? So rather than this, open a bracket, then select this row total into column total divided by this grand total. It is fine.
Fine, ma'am.
I have used the function F4 or F4 key from the keyboard to make it constant. I want, because every time I need to divide this by the 38. I do not want to make changes in this, so I have fixed this cell. Is it okay? May I press enter?
How can we fix the total value?
Using the dollar sign or F4, or maybe I don't know how your system works. You need to check using the F4 or function F4.
Ma'am, after selecting
Okay.
that cell, we have to type dollar or what?
I said using the F4 or function F4 key, or if it is not working, or maybe I don't know how your system is. So you can
Okay.
put dollar also, up to you.
Okay, ma'am.
If you will use function F4 or only F4 keys, that way you do not need to put dollar sign manually. That will directly come. Done?
Yes, ma'am.
Okay.
Press enter. So this is the expected count for wealthy and yes. It is fine. Shall I proceed?
Yes, ma'am.
Fine. Coming to the wealthy and no category. Putting a equal, right? Then selecting the for wealthy and no, that is this 5. So its row total is this multiplied by its column total is this divided by the grand total. Done?
Yes, ma'am.
I'm not using a function F4 because there is no use of putting function F4 or what I can say, making it constant, because once you are dragging the formula, in that case, that is worth, right? But I think I'm not dragging the formula, so I'm directly pressing enter. Now, coming for the middle, in the middle, that is 9. For this 9, the row total is this 16 multiplied by column total is 20 divided by grand total. Done?
Yes, ma'am.
Okay. So now next equal for 7. this divided by this. Done? Shall I proceed?
Yes, ma'am.
Now for the last category, that is poor, this 11 into this 20 divided by 38. Done? Shall I press enter? Yes. Hello.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Fine. For the last equal 11 into 18 divided by 38. So I think we got the expected count. It is done.
Yeah, ma'am.
Fine.
Yes, ma'am.
Now, yeah, now we will get the p-value. Now this is the time to get the p-value for the chi-square test. So here put a equal sign. Use the function CHISQ dot test. Right? This is asking you for the observed frequency range and the expected frequency range. So you need to select carefully only the range of the observed frequency and range of expected frequency. So I have selected the range. Carefully you need to see, and that way you need to select in your laptops or desktops. Done?
Yes, ma'am. Yes, ma'am.
Fine. So pressing enter, it is giving you the p-value. So I think now we are all set to interpret this p-value. So when I say the p-value is 0.84 and you need to compare this p-value with the level of significance, which we are assuming as 5%, right? So when I compare this, so 5% meaning is 0.05. So I can say this thing that this is greater than 0.05, right?
Yes, ma'am.
Done.
Yeah.
So if it is greater than 0.05, that means what will be the conclusion? Anyone?
How to reject the hypothesis and hypothesis.
Sorry?
We reject the hypothesis, that's true.
Your voice is not clear, ma'am.
Reject H naught.
We are rejecting. This is what you are saying.
Reject the hypothesis.
Okay, I think you are saying rejecting the null hypothesis is what I can interpret. I think what I can understand from your voice. Okay, so I think I have already told you the thumb rule of the p-value. If p-value is less than 0.05, in that case, we are rejecting the null hypothesis. But here the p-value is greater than 0.05. That means you need to accept the null hypothesis, right? I hope it's clear.
Yes,
Yes,
ma'am.
ma'am.
It
Yes.
is clear, ma'am.
So if we are accepting the null hypothesis, so a hypothesis will be what? I think I have written the hypothesis for you. You can find the hypothesis is wealthiness status is independent of graduation level. That means there is nothing to have the wealthier status with the education or with the graduation level. Whether the person is graduated or not, it is not to any way affecting the status of wealthy. Is it clear?
Yeah, ma'am. It's clear, ma'am.
Fine. So this way, this was the chi-square goodness of fit. Sorry, chi-square independence of attributes. The next sheet I have provided you for the practice purpose. So you people can use whatever we have just learned. You can apply this thing here in the next sheet, right? Maybe later on. Now we will proceed with the next topic, which is the t-test. I hope I can start with the t-test, right?
Yes,
Sure,
ma'am.
ma'am. Sure.
Fine. So I think I have already shared the sheet with all of you. I hope you people have found the sheet. Yes. Have you people got the sheet? Yes. Any confirmations?
Yes, ma'am.
Fine. So if you people have got the sheet, now I'm starting with the conceptual aspect of the t-test, and then we will see how we can perform these tests using Excel. So here the concept, firstly, I'll discuss about the t-test. Okay. So whenever we are talking about the t-test, firstly, it is a parametric test, which is based on the parameter. So parametric tests are based on the parameters of the population generally. So that way we can say this is a t-test, right? Generally, this is a notion when we talk about t-test and z-test. So the notion is what? That the t-test, when we are using t-test, your sample should be less than and equals to 30. And the standard deviation of population is unknown. These are the two conditions for applying the t-test, right? Then the purpose of t-test is what? Compare the mean difference or compare the mean. That is mean difference, right? So when we talk about t-test, main purpose of t-test is to compare the means in the category. So compare the means of sample and the population, or compare the means of two different samples. This is generally we are talking about in case of the t-test, right? So whenever we are talking about the t-test, t-test can be of generally, if I talk about the types, it can be one sample, and two samples, right? So that t-test is a parametric test. Generally, it is used for comparing the means, right? So comparison of means can be in the sample and population or in the two samples also, right? Then types of t-test is one sample in the two samples t-test. In the one sample t-test, generally, the purpose is what? We are comparing sample mean with population mean, right? And whereas in case of two samples t-test, here the comparison will be means of two samples, right? Then there is one further bifurcation available in the case of two samples t-test, that is independent samples and dependent samples t-test, right? So when I talk about independent samples t-test, samples will be independent or unrelated, right? Then talking about further the variable requirements. Here we need to have generally one dependent variable which will be continuous or on the Likert scale, or sorry, on the interval scale or on the ratio scale, and we need to have one independent variable which will be categorical. This is the variable requirement of the independent sample status. Till here I am clear. Any doubt? Yes.
Yes, ma'am.
It's clear. I am assuming this, right? May I proceed? Yes, sir.
Yes, ma'am. Yes, ma'am.
Yes. So Here, what you are doing, you are comparing the mean of the dependent variable in the categories of the independent variable. So here, one more important thing is that one dependent variable which will be continuous, one independent variable will be which will be categorical, and here the thing is with two categories or groups or samples, right? So that is the important thing. Your independent variable will be categorical, and it should have only the two categories or two groups, right? So to understand this, you can take an example. For example, I want to compare the salary of male employees and female employees. So that way you can find categorical variable will be the gender, and it will be having two groups or two categories, that is male and female. And you want to compare dependent variable, which is salary. Is it clear?
Yes, ma'am.
Fine. Now, talking about the dependent samples. So dependent samples means here the samples will be dependent or related. So how it is possible? How will this be possible? This will be possible when you are taking the same sample twice, right? Say for example, there is a company want to improve the performance of the employees, right? So companies having the present performance of the employees. Now company has introduced training for the employees, and after the training, and company has waited for few months and something, and that way company has recorded the performance of the employees again. So that way for the same employees, companies are having the two performance scores before training and after training, right? So that way this type of case is known as the dependent sample case, where your one sample will be repeated twice. So for the same sample, you are collecting data two times on a particular time gap, right? It is clear?
Yeah, ma'am.
Fine.
Ma'am,
So-
please repeat this last part.
Okay, so I said for when we talk about the dependent samples t-test, the other name for this is the paired samples t-test. So the sample which you are taking, it should be repeated twice. Means for the same sample, you will collect data two times for a particular time gap, or in a particular time gap, you will collect the data two times for the same sample. So that way there will be a pairing for the each unit of the sample, right? Say for example, there are 10 employees of a company. So for in the first conduct, company has recorded the performance score of all the 10 employees, and then after training, company has recorded the score of the same employees again. So for that purpose, you need to understand this thing, that for all the 10 employees, we should have the two performance scores. So there will be pairing in the performance scores. This way, this is known as the dependent sample t-test. I hope it is clear now.
Yes, ma'am.
Okay. So I think this was the conceptual background. Here, one more thing is the variable which you are measuring here will be the continuous variable, right? So continuous variable you are measuring in case of dependent sample t-test, right? Now, to understand all these, we need to see how we can perform these using the Excel. So for the purpose, you need to open your first sheet, which I have named as demo one sample. So shall I start?
Yes, ma'am.
Yeah,
Okay, ma'am.
fine. So now you can see in this, I have given you a single variable, which is the height variable. So here height in inches are mentioned, right? Now, suppose these heights are of the students, those who are studying in suppose college or somewhere, right? So for these students, we want to see whether these heights are belonging to or representing the sample height or population height or not, right? Because in case of one sample t-test, I already explained you need to compare the sample mean with the population mean, right? So always you need to have a rough idea about your population mean. That way only you can compare the sample mean from the population mean. So suppose this is the data which is of the college going students, And we are knowing for those particular students, suppose the on an average height is approximate 66 inches, suppose. Done? I hope it is clear.
Okay.
So shall I
Okay,
proceed?
it's clear.
But ma'am, you said that the standardization of population is unknown. So
I
I'm
said
not
the standardization, I didn't say mean.
okay, ma'am.
Yes. So, and always when I talk about one sample t-test, as I said, the purpose of one sample t-test, because it's one sample. So if you are having a mean, so from which value you will compare it? So you will compare that mean from the population mean. So always you need to have a rough idea about your population mean, right? So maybe,
Yes, ma'am.
yeah, so maybe you can say this thing, say, for example, you are using a Likert scale data. So we know this thing, suppose the Likert scale is 1, 2, 3, 4, 5, right? So we know the average of this is 3. So always you can compare that value from the 3, something like that. So you need to have some idea about your population mean or about that average of that particular scale or something. Only that you can apply the one sample t-test. This is the case, means this is the, what I can say, this is a means this is a kind of limitation we can say of the one sample t-test, because it's one sample, so you need to compare it with something. So that something will be the population. Fine. Shall I proceed?
Yes, ma'am.
Yeah. So I think Saturday when we have seen the first session, I explained you need to add the data add-ins tool pack in your Excel sheet. I hope everyone has added. So I'll show you by going in a data tab. I'll use this data analysis tool pack. You need to go down, as all the tests listed here are the alphabetical order. All the tests are listed here in the alphabetical order. So I'm going down. You can find there are 3 t-tests available. The paired 2 sample form means 2 sample assuming equal variances and assuming unequal variances. But there is no test for the t-test, which is for the one sample, right? So that means this is a limitation of this data analysis tool pack. That means you cannot apply the t-test using this data, one sample t-test using the data analysis tool pack. So that way you need to use this Excel as a calculator only to perform the one sample t-test, right? So that is why I have kept it the formula here. You can see the formula of the t is x bar minus mu divided by s x bar. That is the sample mean minus population mean divided by standard error of mean. Standard error of mean formula is standard deviation divided by square root of n. So you can find I have already given you this formula, you people, to in this particular sheet of this sx bar, right? Now, everything we need to calculate manually. So firstly, I'll calculate the sample mean. Is it fine? Fine, everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Fine. So now,
Yes, ma'am.
yeah. So now you need to use a function here to get the mean. So can anyone tell me what is the function?
Average.
Average. Very good. So I'm using the average function. You need to give the range of your data, close the bracket, and then press enter. I think it is not tough, right? May I press enter?
Right, ma'am.
Yes,
Yes,
yes, yes,
ma'am.
ma'am.
Done. Then I think mu is already given to us, which is 66, right? Then sample size, which you can calculate using the count function.
Ma'am, what is this mu? Mu?
Population mean, this mu.
Okay, okay.
Then you need to calculate the standard deviation, which is SQRT of the size or the range, right? Then
Yes, ma'am.
it is 8.354762. Now, standard error of mean. which is already I have shown you. This is the standard error of mean. So you need to use this standard deviation. This will be divided by the square root of the sample size. Done? Is it clear?
Yes, ma'am.
So I'm pressing enter. So we are getting, this is the standard error of,
N 12 or 14.
sorry,
N is 12 or 14, ma'am.
I think it's 12. You can select it and see. It's 12.
Okay, okay, ma'am.
Okay. So now we will get here the t value, t calculated value you need to calculate here. So for that, suppose I will calculate this in the two part. I'll calculate firstly the numerator of my formula and then denominator of my formula, right? So numerator is what? It is x bar minus mu. X bar is this minus mu. It is clear?
Yes, ma'am.
Fine. Now denominator is what? Which is already we have calculated, which is this. Now the t calculated will be its numerator divided by denominator. Done?
Yes, ma'am.
Now we are having the t calculated value. Now we will calculate the p value. So suppose we have applied this for the two-tailed test. So two-tailed t-test p value formula is t dot dist dot 2t. It is requiring the calculated value, which is this, and the degrees of freedom, which is 12 minus 1. Done?
Ma'am, please tell the formula again.
Ma'am, can you please repeat once again?
From where?
From
Ma'am, P
for the
value.
P value, ma'am.
I think this is already written. The function is t dot dis dot 2t. It is requiring up. You can see it is already available in your sheet. It is asking the calculated t. So you need to select the cell. Calculated t value I have given here. And the degrees of freedom formula I already told you I think yesterday or day before yesterday. It is n minus 1. N is this. So this minus 1. Done?
Ma'am, one doubt.
Hmm.
Standard deviation, which formula is used for finding out the value of standard deviation?
Which formula means?
Standard deviation, SD, square root of range of
Oh.
observation, is it?
Sorry. I have used the wrong formula. It is STDEV.
Yeah. Okay.
Done? Thank you. I think in hurry I have used the square root.
Yeah. I think so.
Fine. Everyone has found this. The same values everyone is getting like mine.
So maybe there is change in other values, standard error.
Sorry?
Is there any change that will happen?
Already it has changed. Ma'am. You see, because already it has changed.
Okay.
Because we have
Okay.
used this formula. Yes, it is already changed.
Right.
Fine. So this is your p value. So shall I start making what I can say, the interpretation of this now? Yes, friends.
Sure, ma'am. But ma'am, there is some noise. We are not listening properly, ma'am. Can you please
Yeah.
ask him to mute, ma'am?
Okay, I
Yes,
don't know
ma'am.
who
There
is.
is some background noise, ma'am.
Okay. So this is a humble request. If you are not speaking, not interacting, please mute yourself. I don't know who is this. Now fine.
Ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Fine. Okay, so we got the p-value. Here you can see the p-value is greater than 0.0, sorry, is less than 0.05, right? Is it fine?
Yes, ma'am.
Ma'am, can you determine of
Yes, ma'am.
p-value?
Sorry?
Can you repeat the whole p-value?
Ma'am, already given in your sheet. I don't think so. I need to repeat. You can check the sheet I shared with you. It is already given there. Degrees of freedom, if you people want to write, you can write there. It is n-1.
N
Right?
minus.
Yeah.
Okay.
So it is done.
Ma'am, excuse me.
Hmm.
Can you define degree of freedom?
Degrees of freedom is the freedom of the what I can say number of variable. How many number of categories can be free? That is the degrees of freedom. For example, suppose there is a bus, right? There are only 5 seats available. So 5 people are entering, right? So first people is having the choice of taking any of the seat. Second person will having the choice of taking any of the remaining 4 seat. Next person will be having the choice of occupying the remaining 3 seats likewise. But the last person will not
Yes,
having any choice. So whatever seat will be remaining, he or she needs
yes,
to
ma'am.
occupy the same. That is the degrees of freedom.
Oh, thank you so much, ma'am.
Yes. Okay, fine. So may I proceed with the interpretation part now? Yes.
Yes, ma'am.
Fine. Now you can see if I talk about the interpretation. So I have compared this value with the p-value, sorry, with the level of significance, which is 5%. So this is less than 0.05. So if it is less than 0.05, that means we need to reject. Yes, very correct. Reject the null hypothesis. Very correct. Right? So we are not accepting the null hypothesis. So what will be a hypothesis here? I think we forgot to formulate. That is the first step. So it is, there is,
Sample mean is
very good.
66. That be there is no significance.
There is no significant difference between the sample mean and the population mean, ma'am.
Very correct. So this is the null hypothesis we are not accepting. So that means alternatively, you need to say that there is a significant difference in the sample and the population mean, right? That means sample mean and population mean are not similar. They are quite different. Getting me?
Yes, ma'am.
Yes, ma'am.
So shall I proceed with the next test now?
Yes.
Fine. So you people need to see next sheet is the practice one sheet, which is for the this one sample t-test, which you can perform by your own afterwards, right? I'll come to the next sheet named as demo independent. Here you can see, suppose we are having, firstly you need to identify how many variables available here. Anyone?
Two variable, ma'am.
Two
Okay,
variable, ma'am.
can you name which two?
The study hours
Male
and
and female.
the gender.
Gender.
Very good. Study
Gender
hours.
and study hours. Yeah.
Very good. We are having the study hours, which we can say it is our continuous variable. And second is the gender, which is the
Category.
categorical variable with 2 categories, right? Done? Done? Friends,
Yes,
done?
ma'am.
Yeah.
Now the important thing here is to what is the important thing here which you need to understand is that whenever we talk about Excel, generally Excel is little different from the other software. Here the data format will be different, right? How it will be different? You need to see your data which is listed here in the form of the categories. That means what is the study hours of the female student? These are mentioned in the one row or one column. Similarly, the male study hours are mentioned in the one row or one column. Likewise, right? Whereas when we are collecting the data, that is in the different form. If anyone can understand, I think I'm copying it here. Generally, when we collect the data will be usually in this form, right? Yes or no? I think you people are
Yes, ma'am.
performing, yeah, you people are collecting the data, so you are knowing this thing. Generally, when we are collecting the data using the Google form, etc., this data will be generally in this form, right? So what you need to do if your data is in this form, using the filter option, you need to bifurcate your data in this form. One category data will be in the one particular row or in a column, and second category data will be in the other row and column. This is the important thing you need to keep in the mind when you are using Excel for performing these type of tests. It is clear? May I proceed?
Sure, ma'am.
Yes, ma'am.
Yes. Yes.
Yeah, ma'am. Please proceed, ma'am.
Yeah. Now you can see just now you can see if we have seen that we are having one continuous variable, one categorical variable with the two categories, and if we are interested to find the difference in these two categories for this continuous variable, means hypothesis will be what? Anyone? Yes. Any attempt?
Mean of study hours
Hmm.
and gender
Hmm.
are equal. Is there any significant difference between mean of study hours and gender?
Okay, fine. Okay. Anyone else? It is okay? Or any changes?
There is no significant difference between study gender
Hmm.
with respect to study hours.
Okay. Fine. Anything else? Okay. Here you need to compare the study hours. We cannot compare gender with the study hours. It is illogical to compare study hours with the gender. Wherein we want to compare the study hours of male and female students, right? So we will write here, there is no significant difference
Difference
in
between
the
study hours of male and female.
mean study hours of male and female students, right? Fine. Done. I hope clear to everyone.
Yes, ma'am.
Yes, yes.
So if it is clear, now I think we are all set for getting the output. So for that, firstly, you need to go to the data tab. And then in this, you will go to the data analysis. There, go down and see, I already shown you these two things. Here you can find that we are having here the two choices of the independent sample status. First one is assuming equal variance, and second one is assuming unequal variances, right? So usually there is one assumption of the t-test which is about the equal variances. Generally, your data should follow the equal variance. This is the assumption, but you need to check whether the data is having equal variance or not. So in that case, you need to firstly check whether the variance is equal or not. Usually when I teach this to the students, usually what I generally suggest to students, when you're not having the idea of variance, you can go for the unequal variances. But here, being a researcher, being a faculty or academician or academia field you people are, you can go firstly and check whether the variance is equal or not. For that, you need to select here this F test to sample for variances. I hope everyone has found it.
Ma'am,
Hmm.
ma'am, I could not follow the process. Can you please repeat, ma'am, once again?
Which process you haven't followed, sir?
Ma'am, that F test, ma'am.
I think I haven't told any process right now. I have just shown you. You need to just select the F test to sample for variances.
Oh,
I
okay,
haven't
ma'am.
explained any procedure till now. I just said
Okay,
you
ma'am.
need to check whether the variance is equal or not using this F test. Done?
Yeah, ma'am. Yeah, please, ma'am.
So you need to click on the OK button here. So the box will be open for you, which is requiring or demanding the two ranges, variable 1 range and variable 2 range. So here I am selecting my first category, that is female. For that I have given a range. In the second box I have given the range for the male category. I hope it is done. Not a tough thing to do. Done? Shall I proceed?
Yes, ma'am.
Done. Then I have selected my data, including the labels of my column. So I'm selecting this labels box. Alpha value is by default 5%. So I'll go with this. Output options, I'm selecting the first one and clicking on this box. And then selecting a blank cell of my sheet. And then you need to press on OK. So I think I'm done. May I press OK?
Okay, ma'am.
Yeah. So in a click, you will get the output. I hope output is visible to everyone.
Yes, ma'am.
Now you
Yes,
can
ma'am.
see here, yeah. Now you can see here we are getting the F test to sample for variances, which is giving you the output in terms of mean variances. So firstly, the mean of the study hours is given for male and female. Variances in the study hours is given for the male and female. Total observations for both the categories are given and degrees of freedom are given. F value, which is the calculated value, which is coming as 7.373272. Then the F value for, then the P value for the one tail and the F critical for the one tail is coming. So you can convert this value in the two tail. So how you can convert the P two tail value?
Divided by 2.
Multiplied by 2.
Sorry.
So it is equal this into 2. Done?
Yeah, ma'am.
So shall I press enter?
Yes, ma'am.
Done. So once you are pressing enter, you are getting the P value for the two tail, right? Now you can compare this P value from the level of significance, which is 0.05. So you can say your P value is greater than 0.05, right? So in that case, you need to hold the null hypothesis, right? You cannot reject the null hypothesis. Done? Done? Yes, any confirmations?
Yes, ma'am.
Ma'am, what was the hypothesis? Please show.
Hypothesis I have not written for this F test. I am writing the hypothesis now. Hypothesis for the F test is variance is equal. That hypothesis which I have shown you, that is for the T test. Here we are talking about the F test. So F test
Okay.
hypothesis variance is equal. So that means we need to hold the null hypothesis, which is saying the variance is equal. So that means now it is clear. We will apply the T test to sample for the equal variances. It is clear now?
Yes, ma'am.
Yes, ma'am.
So now I'll go to, now you can see this is the hypothesis. I don't know who is asking me. You can check the hypothesis here. Fine. Yes, shall I proceed?
Yes, ma'am.
Done. Now we'll go to the data analysis, and then I'll go down and select t-test to sample assuming equal variances. Done.
Okay, ma'am.
Then clicking on OK. This is requiring following information. In the first variable range, again I'm selecting the female data. In the second cell, I'm selecting the male data. Hypothesize mean difference, you do not need to pass anything. This will be blank, or maybe you can put a 0 here. Labels I'm selecting because I selected my data including the labels. Alpha is 0.05, right? Output I'm generating in the same sheet. It is done. Done, friends?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So now you can press on OK to get the output, and I think it is generated now. Now you can check the mean for the male. I think it is very similar, which we have got in case of F also, right? So the mean study variance, mean study hours, variance in the study hours, observations are listed here. Pooled variance, which is coming as 98.53 because it is the equal variances. So pooled variances is calculated by the Excel, right? Now standard hypothesized mean, we haven't passed anything, so it is coming as 0. Degrees of freedom is 9. T statistic, which is the calculated value of your T, which is 1.36. The P value for the one tail, critical value for the one tail, P value for the two tail, critical value for the two tail. So I always go with the critical value of the two tail. So I'm critical value or the P value of the two tail I'm going with. So here you can check. I need to compare my P value with the 0.05. So that is greater than 0.05, right? It is clear?
Yes, ma'am.
Yeah. So if it is greater than 0.05, that means what I need to do?
Accept the null hypothesis.
Very good. Accept the null hypothesis. Very correct. So we are accepting the null hypothesis of the t-test now. So you can see the t-test hypothesis says that there is no significant difference in the mean study hours of male and female students. That means our test is saying the mean study hours or the total hours total hours studied done by male and female is almost similar. There is no difference is coming. It is clear?
Yes, ma'am.
So this way, this was the independent samples t-test. Now next sheet is for you people for practicing this, that you can do, I hope, right? I'll come to the last sheet, second last sheet named as paired. I hope it's visible.
Yes, ma'am.
Fine. So now we will see that how we can perform paired sample t-test using the Excel. So there you can find there is weights in pounds is given. Suppose there is a diet plan, right? So I think data is of 10 people, right? 8 people, right? So suppose there are 8 people, those who want to opt for any diet plan. So before opting the diet plan, they have taken their weights, right? So these are the before diet plan weights, right? After adopting these diet plans, after some times, again their weights was measured. So these are the weight after the diet plan. Is it clear?
Yes, ma'am.
Now we want to see that I think, can anyone tell me this is a perfect situation for the paired sample t-test or not? Yes.
Yes, ma'am.
Okay, so sir, can you tell me what is the situation for the paired t-test?
The weight has been taken for the same person before the diet plan and after the diet plan.
Very correct. So that means there is a pairing in the weight of the people, right? Before and after, while data is given, pre and post kind of things are there. So that way you can find this is a case of paired samples t-test, and for the same 8 people, the weights are given. So this is the case of paired sample t-test. Now, firstly, you need to formulate the hypothesis. What will be the hypothesis here? Anyone?
There is no significant difference between the weights before and after the diet plan.
Okay. There is no significant difference in the mean weight before and after the diet plan. Very good. Or other way around, I can say, maybe I can make the alternative also. Then done, everyone?
Yes, ma'am.
Done. Now, to apply the paired sample t-test, again you need to go to the data tab, go to the data analysis, and then select t-test paired 2 samples for mean. So, shall I select this?
Yes, ma'am.
Click on OK, and then in the first range, you need to give the weight of the people before opting the diet, and the same people after after opting the diet plan. So these are the 2 ranges we provided. Hypothesize mean difference will nothing you need to give, or you can type here 0. Labels I am selecting because I selected my data, including the labels. Alpha is 0.05. Output I want to generate in the same sheet, and I am selecting a blank set. I think it is all. So shall I?
Yes, ma'am.
Okay, clicking on OK. It is generating the output for me. Now you can check the output. Output says the before diet plan mean weight is this. After diet plan mean weight is this. Variance in the diet before and after is mentioned. Observations were 8 and 8. Always when you are applying the paired sample t-test, you will always get the Pearson's correlation, which is measuring the relationship between the variables, because for the same type of people you are collecting the data, there is a pairing in the data, right? So this way the correlation will come. This correlation is indicating that is a negative correlation. So on value is 0.17, which is a weak kind of correlation, right? Hypothesized mean, we haven't passed anything. It is coming as 0. Degrees of freedom is 7. Calculated t-value is 3.706. P value for the one tail, critical value for the one tail, p value for the two tail, and critical value for the two tail. So I'm considering this p value, which is the two tail p value. I can compare this with the 0.05. So what will be the comparison? Anyone?
It is less than 0.05.
Very good. It is less than 0.05. So what I need to do?
Except the null hypothesis.
We will reject the null hypothesis.
Reject the null hypothesis.
Reject.
Yeah, we will reject the null hypothesis.
Sorry,
And when I'm
reject.
rejecting the no issues, when we are rejecting the null hypothesis, you can find the null hypothesis when we are rejecting. Alternatively, we are saying there is a significant difference in the mean weight before and after the diet, right? So now you need to check before diet the mean weight was more or less, whatever you can see. You can come back to your calculations or your analysis. You can find before diet mean weight was 169.625. After that it was 150.25. So what is the interpretation from this value? Anyone?
That there is significant
diet,
difference in weight after diet.
Yes, after diet weight has reduced, right? That means diet plan is effective, right?
Right, ma'am.
Right. So this was the paired sample status. Now you can see the last sheet I have given you for the practicing of this paired sample status that you can do. So now I'll conclude the session. The session which I have taken on the t-test is generally when we talk about t-test is generally used for finding the significant mean difference, right? Difference, but in the mean form. As you can see, in all the cases we have written here. In case of independent samples, also have written here mean study hours. In the paired case, also have written here the mean weight and all. So whenever you are interested to compare mean weight or mean of the dependent variable or the continuous variable, you can use generally the t-test, right? T-test is a parametric test because when we talk about the t-test, it is considering the parameters of population, like mu, which you have seen. Mu is the population mean, which is one of the parameters of population. So likewise, for other t-tests also we are considering these things. So that is why t-test is known as the parametric test. Then I explained you the variety in the t-test, that is one sample and the two samples. So one sample means when we are having only a single sample, in that case you will compare its mean from the population mean. So that means you need to have some rough idea about the population mean. That way you can compare. That way you can perform the one sample t-test, right? In Excel, limitation is that you can use Excel as a calculator only for the one sample t-test, because there is no what I can say in the data analysis toolpack, you cannot find that the value of that t-test, right? Or the t-test option, you cannot find one sample t-test. So that way we are using the t-test as a we are using Excel as a calculator. Further, I talked about the independent and the dependent samples t-test, which are the two samples t-test. Independent samples means that groups or the samples will be unrelated. As you can see, male and female. So generally when I talk about male and female, these are the two unrelated groups, because male cannot be the part of female category or female cannot be part of male category likewise. So these groups are unrelated, right? So that thing you need to check by yourself, by or maybe while collecting the data and all, right? And then you will compare the mean of your continuous variable in these two categories for the independent samples t-test, right? So that is the important thing I explained to you. I think one thing I need to tell you is that here if you have seen, in case of female, we were having total the 6 females data, but in case of male, we are having only the 5 males data. So that means here there is no problem. Here, it like in both the categories, it is not necessary that number of observations should be same. But whereas we are talking about the paired sample status, here we are talking about the pairing, and for the same person you need to collect the data twice. So that way it is not like, suppose if you are not having this variable data, in that case you cannot perform the t-test, right? So you need to see this thing, which is the important one, right? So paired sample t-test is what it will help you to compare again the significant mean difference, or it will again help you to compare the mean of the two different samples. But those sample will be one, but for the same sample you will collect the data twice. So wherever you are looking, or wherever you are having the situation like before, after, pre and post kind of thing, in that case generally we are performing the paired sample t-test when the purpose is to find the mean difference, right? So this way, this was the overall summary of the t-test which I explained you. Now I think I'm ready to take questions. If you are having any question, you please ask. Yes. I hope you are listening to me.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes. So if you people are having any queries, please ask. No queries?
What does this Pearson correlation signify here, ma'am? This
Whenever
Pearson correlation. Yes, ma'am.
whenever you are talking about the paired sample status, because there will be pairing in the data. So for that purpose, any software, whether it is Excel or any other software, will always generate the correlation for you to tell you the correlation or the relationship between the pairs.
So if it is positive, ma'am, then there is a strong correlation. Is it?
No. Positivity is based on the value of R. I think, sir, that we will study when I'll take the session on correlation. That is, I think, second last session. So that
Okay,
I'll
ma'am.
explain you that how you can understand strongness and what is the positive and negative, that I'll explain.
Ma'am, I have a small doubt. When we were doing F test, you used a word called we hold null hypothesis, and I understood the accepting the null hypothesis. And there's one more term which you use, rejected the null hypothesis. Ma'am, could you please elaborate on hold null hypothesis when we were doing F test for two samples for various?
Usually, sir, means it is like when I studied this, what I can say, statistics. Usually,
Yeah,
it is like we cannot say this thing rejecting or accepting generally, because we are dealing with a small data set and we are generally concluding for the entire data or entire population. So generally, hold or something words generally we are using, and generally, or we are generally saying it is because of means by chance or something like that. So generally, you cannot write reject and accept type of things. You generally write do not accept, do not reject, something like you need to write. So that is why generally I'm using hold also, but
Okay.
meaning is almost similar.
Okay. Thanks, ma'am.
Yes.
Ma'am,
Any
I have a question. Ma'am, this is Dr. Navleen. I have a query. Ma'am, I just want to know if you can elaborate again what is the difference between one-tailed and two-tailed test?
One-tailed and two-tailed, ma'am. Two-tailed means when the direction is not clear. That means it can be greater than or less than in both the direction it can go. But when we are talking about two tails, when you are talking about one tail, direction is clear. Means it is great. Means you are saying sample mean is greater than or less than. So it is direction is very clear. But in the two tail you are writing there is no significant difference, or there is a significant difference. So that difference is greater than and less than, that you are not mentioning. That means it is a two tailed.
Okay, ma'am. Thank you, ma'am.
Ma'am,
Yes, sir.
regarding that alpha value that you have told that it should be 0.05. So can we consider that alpha value 0.01 or 0.001, ma'am? On what basis, ma'am?
I think, sir, I think you are listening to me from the first day. I told this thing, it is depending upon totally the researcher, and maybe you can see in which field you are working. So the alpha value generally depending upon that. So how much you are confident about your conclusions, how much risk you are expecting, that you need to decide. Usually, I said generally use percent are 1, 5, and 10, but it is not mandatory, up to the researcher.
Okay, ma'am, got it, ma'am.
Yes, sir.
Excuse me,
Yes,
ma'am.
sir.
Can we have can it be have sessions on secondary data as well, ma'am?
Sir, right now, I think this FDP is for the this thing only. But if you are having any query regarding your secondary data, means generally we can perform these tests on the secondary data also. But what is your exact requirement? If you can tell me accordingly, we can plan in future.
Like, ma'am, to analyze the financial reports of company or the industry or the economy, certain like data basis on that, ma'am.
Using statistical tool you are talking about, or you are generally talking about the analysis of the financial reports?
Ma'am, statistical tools only.
Okay, so sir, I think means suppose you are having two companies. Suppose I'm not sure what data you are having, and if you want to compare their profits and all, sales and all, etc. So in that case, these tests which we are discussing, these can be applied, but depending what type of data you are having. So if you can tell me what is you are having or what you want to perform accordingly, I think maybe I can help you out.
Okay, ma'am. Like, say, we are comparing, we are analyzing the ratios of different companies, 10 companies or more than 10 companies. We are analyzing the sales, like profit and these variables, and what kind of test we can apply on that. Means two sample or one sample test, or like.
Sir, if you want to compare, as you have seen this thing, that there is a limitation of t-test. T-test only compare the two categories. So when you are having the ratios of two companies, right? Say for example, you are having certain profitability ratios and you want to compare two firms. So that way you can apply the t-test, but t-test can only compare the two companies at a time. So that way you can make pair. First and second you can compare, first and third you can compare. But for further, if you want to compare all the companies' profit or these ratios together, in that case, we will be having the other option, that is ANOVA test.
Okay, ma'am. Okay.
Ma'am, I have one more query, ma'am. So, what may be the possible sources of error during such kind of measurements, ma'am, when we take the primary data? What may be the sources of error, ma'am, in case of testing those hypotheses?
Error in case of primary data, the first one is the sampling error, if you have heard about. Sampling error means when you are collecting the data and you are not using the appropriate sampling method, that can create a problem for you. Generally, most of the time we are using the convenience sampling. In convenience sampling, you need to be very much sure from the people you are asking to fill the data. You need to understand this thing, that person is having the good idea about that thing. That is the one thing. Sample should be correct. Suppose you are asking about any product or services, so the person should be using those things. So these are the some of the errors which you need to take in care. Apart from that, non-sampling errors may be like, if you are talking about your questionnaire, it should be well framed. Question should be very much relevant and should be very clear and concise. Should be means only depicting the one meaning of a sentence or something like that. So these are the small things. These you need to keep in your mind while collecting the data, sir. These things can create problem if people are not getting your statements properly. So whatever way they are getting, they will respond you accordingly. These all things can lead to the misconclusion or the bad results.
Okay, ma'am.
Yes. Anything else?
Ma'am, just wanted to know that for secondary data when we use, what tools can we use for bibliometric analysis?
For bibliometric analysis, ma'am, there are like a dimension is available. You can use dimension. Then NVivo, this bibliometric NVivo I haven't applied till now, but dimensions I applied. Walls viewer you can use. Dimension can help you to get the data, right? And walls viewer you can use for applying the bibliometric analysis.
Ma'am, are there any engineering applications where I can apply these techniques?
Sorry?
Are there some engineering applications where I can
application
perform these tests?
depending upon, as I said, Miss, I think we haven't talked about in terms of the hardcore RM and all, but when you are dealing with Miss, as you can see, suppose you want to compare the what I can say in terms of engineering, if I want to say, for example, heat or something, if you want to compare like these, right? So that way you
Okay.
can, there is no problem. Gauge, etc. These type of things, if you want to compare of the two products and all, you're having certain types of calculation, certain types of measurement of two different things. So that way you can see that there is a significant difference existing in the average gauge or something like that. This means the words I'm not much clear about, but these
Okay. Suppose I am doing welding on a specimen by using two different processes.
yeah, that way you can do this.
So for those two lots, I can make the comparison using
You
these.
can make, you can
Yeah.
make. So there is no problem.
Okay. Okay. Thank you.
Yes. Okay, I hope no more questions. So can we call off a meeting for the day?
Yes, ma'am. Yes.
Yeah. Okay, so thank you, everyone.
Thank you, ma'am. Thank you.
Yeah,
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you so much, everyone. So, Yograj sir, we are done. Thank you so much.
Thanks a lot.